Hello everyone. Today I would like to introduce MCC rectifiers. So, what is rectifier? Rectifiers is basically a semiconductor device that's designed to allow current to flow in one direction only. It could be effectively used to convert alternating current into direct currents. So if you look at the curve over here, you can see this is the forward bias, and it allows current to flow in the forward directions. But when it comes to the opposite directions, basically you have the breakdown voltage as well as the reverse working voltage, and it blocks the opposite directions of current flow until the breakdowns of the device. And this is the basic symbols of diodes. So you have an arrow as well as a one line to indicate the cathode, and the other side is basically the anode. Okay? So diodes is also a critical component in power supply design, where you can actually find it in a lot of power supply. So how does rectifiers work? Basically, as I explained just now, it blocks the current in reverse directions, but it only allows it in the forward directions. And definitely, we were talking about rectifiers, so we are looking at the high current capacities. So rectifiers are actually built to handle high currents, so which make them suitable for applications like power rectifications and suitable for applications in power supplies. So one of the key points over here we would like to achieve is also to make rectifiers having a low forward voltage. So this is in order to minimize the power losses when the current flows through the rectifier. So how do we categorize the rectifiers? And basically in the market, you will find 4 types of rectifiers. And we have the standard recovery rectifiers. And we also have the fast recovery rectifiers. And nowadays we have the super fast recovery rectifiers, as well as we have the Schottky barrier rectifiers. So each of them have their own advantages and disadvantages. If you look at the switching speed, we could use the reverse recovery time to indicate the switching speed of each categories of rectifiers. So for standard recovery rectifiers, normally you will have the reverse recovery times of more than 500 nanoseconds. For fast recoveries, basically the time will falls in between 150 nanoseconds to 500 nanoseconds. And for super fast recoveries, we have the reverse recovery time, which is less than 150 nanoseconds. And basically, Schottky barrier rectifiers, you will see the reverse recovery time in the range below 20 nanoseconds. So you can see each of them has their own benefits and disadvantages. So standard recoveries, of course, is low cost. Basically, it is used in rectifications. And fast recoveries and super fast recovery, basically you use them in switching. You use them in switching for high frequency and as well as for moderate switching frequency. So Schottky barrier rectifiers is used in ultra fast switchings. So basically you would like to have a very fast type of switching applications, such as in the RF applications or in high-speed DC-DC converters. So this one, normally you will use Schottky barriers rectifier. So how do you differentiate between diodes and rectifiers? So in MCC, we categorize small signal diodes by using the parameters called forward currents. So for forward currents less than 0.5 ampere, which is 500 milliamps, so that is the point that we differentiate between diodes and rectifiers. Right. So forward currents greater than 500 milliamperes, we will classify as the rectifiers. So as mentioned just now, rectifiers is categorized into 4 categories, and each categories has their own different type of behaviors. So standard fast and super fast recovery rectifiers are designed with PN junction structures. So basically they have higher forward voltage, and but of course they could achieve a very high breakdown voltage. But for Schottky barrier rectifiers, this is metal barrier design, but the advantage of it is low forward voltage, and the disadvantage, of course, is lower breakdown voltage. So normally in the market, Schottky barrier rectifiers is only capable to up to 300 watt of breakdown voltage. In MCC, we have about 1,300 rectifiers in our portfolio. Among them, we actually categorize into automotive and non-automotive as well. So, and each categories come with the Schottky standards, super fast as well as the super fast recoveries rectifiers. So these are the packages offered by MCC. So for XL leaders, so these are the common packages that we will actually find in the markets. For example, like the O41, the O15, as well as the R6 package. And for through-hole packages, you could find the TO220. These are all the common packages, including the isolated TO220, as well as the TO247. And we also included the TO264 in our portfolio. For surface mounts packages, we have the leaded as well as the leadless. And for the leaded package, you could find the standard industrial package, such as the D-pack, the D2 pack, and the TO263 AC, and as well as the TO277. And for smaller package, we have the SOD 323, SOD 123, and SMA, SMB, SMC. And for the flat lead type, we also have the TO221 AC, so which is known as SMAF as well, and SMBF. We also have the flat lead type. And for the leadless package, we have the DFN 5060 package to offer. If we dive further into our standard recoveries rectifier portfolio, you could see we have about 190 devices in our portfolio, and about 1/4 of them are actually automotive qualified. Okay. So if you look at the tables over here, so this is the heat map that show you the common voltages as well as the common forward currents or the average rectified current. So 400, 600, 800, and 1000 volts are the common packages. So we have a lot of options or more devices offered in our portfolio. So the red colors will indicate we have multiple options or multiple packages available for consumers to choose on. So 1 amperes, 2 amperes, 3 amperes, these are all the common rectifiers, and covering the voltage range of 400 to 1000 volt. We also have rectifiers in the high voltage range up to 4000 volt. the one that is commonly used in the market is in between 1600 volts to 2000 volts. So for high voltages, we have the rectifiers, standard rectifiers in the current range of 30 amperes up to 60 amperes. And for 600 watt devices, we have the current range of 20 to 25 amperes for the high current versions. This is another heat map that show you the packages against the voltages offered. So as I mentioned just now, 400 volt to 1000 volts, we have a lot of options available. So these categories over here, which is the SMA, SMB, and SMC packages, are common packages that offer in the range of 400 volt to 1000 volts. So if you are looking at smaller packages such as the SOD 323 and SOD 123, we also have 400 volts to 1000 volts. And for those through hole packages such as the TO263, TO220, TO247s, so basically it covers the range for higher voltage, about 1600 volts, as well as 600 volts devices. So the next one is the fast recovery rectifier portfolio. So fast recovery rectifier portfolio, we offer about 680 plus devices in this portfolio, basically covering for all the non-automotive standards. And this is the voltage range that we offer, from 50 volts all the way up to 2000 volts in the range of 0.5 ampere up to 10 amperes. Again, this one show you the common available parts is in the range of 200 volts up to 1000 volts in the current range of 1 ampere up to 3 ampere. So in terms of package wise, these are the packages offered. So we have SMABC. So we also have the small packages as well as those XL leaded packages. And this is basically the 400 volts up to 1000 volts of devices that we offer in varieties of packages. So super fast recovery rectifiers is the market trends right now, and you will see a lot more and more applications or more and more design will actually choose super fast recovery rectifiers. So one of the main things is to have a very fast recovery stage, which could help to eliminate the EMI issues. So in super fast recovery rectifiers portfolios, we have about 380 devices, and about 10% of them are actually AECQ qualified. So when you look at the heat map, so you can see again the range of super fast recovery rectifiers that offered by MCC basically cover the range from 200 volts all the way up to 1200 volts. So we offered varieties of the rectified currents in the range from 1 amperes all the way up to 100 amperes. So the most popular one is fall between 1 amperes all the way up to 30 amperes as well as 60 amperes. And the popular voltages, normally we talk about 200 volts. So 200 volt basically, some of the design is used to replace the shocking barrier rectifiers. And 400 and 600 volts, basically you can find it in a lot of power supplies or flyback power supply designs. So let us look at the packages that offered by the super fast recovery rectifiers. So we have quite a number of packages over here covering almost all the packages that we mentioned just now. We have the accelerated package from Diode-41 all the way up to the R6 packages. We also have the small packages such as the SOD123, and then we have the SMA-ABC, including the flat-lit versions. We also have the D-pack as well as the D2-pack for the industrial standards, and the TO220 and TO247s that has been used in the high power applications. So again, as I mentioned just now, we have 200 volts all the way up to 1200 volt of options available for the super fast recovery rectifiers. And those rate indicates that we have quite numbers of versions, I mean the options available for consumers to choose. And we offer different varieties of average rectified currents for engineers or for consumers to choose. So these are some of the examples of our super fast recovery rectifiers, talking about 600 volt devices. So we have a few parts over here from 2 amperes all the way up to 30 amperes. So it is come in different packages. You will notice that when the average rectified currents goes up, basically you will have bigger packages or high power density packages. So this is the TRR that we mentioned just now. So this is the reverse recovery time. So you can see this is super fast, which we target about less than 150 nanoseconds. So you can see the TRR mentions over here is about 35 nanoseconds. So the next one, I would like to talk about Schottky barrier rectifiers. So in MCC Schottky barrier rectifiers portfolio, we have about 670 devices, and it covers the range from 15 volts all the way up to 300 volts. So we also provide options of currents in the range of 1 ampere all the way up to 100 amperes. So again, if you look at the heat map itself, so 1 amperes, 2 amperes, 3 amperes, 5 amperes, 10 amperes, 20, 30, and 40 amperes are those common options available. And 40 volts, 45 volts, 60 volts, 100 volts, 150 volts, 200 volts. So these are all the common voltages for the Schottky barrier rectifiers. Let's just look at what are the packages offered by MCC for Schottky barrier rectifiers. So these are the options of that offered by MCC for Schottky barrier rectifiers. So we have the bleedless package as mentioned just now, DFM 5060s. So covering the range of 45 volt as well as 60 volts, 100 volt up to 200 volts. For small signal Schottky barrier rectifiers, we have the small packages such as SOD323 as well as SOD123 that come in for 20 volts all the way up to 200 volts. So for 300 watt devices, we have the TO227, the TO277. We also have the D-pack versions of Schottky barrier rectifiers. And you can see over here 40 watts, 60 watts, 100 watt, 150, 100, 200 watts. This one we have varieties of options available in packages such as SMA, SMB, SMC, and there are standard industrial packages such as D-pack as well as D2-pack, and the true hole packages, TO220, as well as the isolated, the full pack versions of TO220 as well. So this page shows you some examples of the industrial grades or the non-automotive grades of Schottky barrier rectifiers in 100 watt range. So these are all the 100-watt devices, and the currents, the rectified currents offered is from 3 amperes all the way up to 60 amperes. So it comes in single channel configurations or dual channel configurations. So this is the dual channel configurations. Basically, you have two Schottky barrier rectifiers in one package. So each of them could carry up to 10 amperes, and two of them could give you a 20 amperes of rectified currents. So if you look at the forward voltage over here, because this is the characteristics of Schottky barrier rectifiers, thus you will see a lower forward voltage in the range below 1 volt. Again, if you look at the packages offered over here, for smaller currents, you need smaller packages. For higher currents, you will need those high power density packages such as D-pack, D2-pack, or the TTO220 package. These are some of the examples for automotive grade Schottky barrier rectifiers. Again, these are all the 100-watt devices. So we have the range from 3 amperes up to 15 amperes. We have one of it is 30 amperes over here, which is in common cathode configurations, and it comes with the D2-pack package. Again, you can see high currents will require a high power density package, such as the D-pack, D2-pack, or the TO277 package. Let us look at some of the application examples. So for rectifiers, it could be used in RF equipments. So in terms of demodulations, you will see some of the Schottky barrier rectifiers or super fast recovery rectifiers being used. So in terms of ESD protections, normally engineers will use Schottky barrier rectifiers. Or you could actually utilize the standard recovery rectifiers. And we also have freewheeling diodes. Super fast recovery rectifiers is one of the options, or Schottky barrier rectifiers. In terms of DC-DC converters, so Schottky barrier rectifiers is most welcome in these applications, and as well as the rectifications, power rectifications from alternating currents to direct currents, and priority protections that we utilize as standard recovery rectifiers. So these are some of the AC to DC applications that you will find a lot of rectifiers in the design. So for examples, such as power supply, AC-DC power supply. So the first thing is for rectifications, AC to DC. So battery chargers, so one of the application, UPS, motor drive as well. You will find some of the rectifiers. And welding machines, you will find some of the power rectifiers. Normally, they will use those high power types of rectifiers, such as in the XL leaded, such as the R6 versions. So these are basically some of the rectifiers applications in AC/DC applications. Well, that's all I would like to cover for today. Thank you very much.